Welcome back, dear friends. Our series on identity shifts, the self-concept, neuroplasticity, and the neuroscience of visualization gave us our first glimpse into how neural networks function. But to truly understand deep learning, we must revisit some of those ideas, this time with more precision. As always, we walk on two paths at once: artificial intelligence and personal development. Because mastering neural networks is not so different from mastering ourselves. When we attempt an identity shift, we often focus on behavior. I want to work out. I want to wake up earlier. I want to eat better. But the brain does not adopt tasks. It adopts identities. Repeated behavior creates nervous system familiarity. Familiarity creates emotional safety. And emotional safety allows us to embody a new self-image. That lifestyle change we dream about is not a dramatic transformation. It is a network of micro-habits, a system, a structure. And this is where we introduce one of the most fundamental concepts in deep learning: the computational graph. A neural network is developed to fulfill a given purpose. When using any app we can think of, we instruct it some values, be it a command or a selection, and expect a result which responds to our query. The computations through which our input leads to the output the app delivers are not visible to our eye. Therefore, a neural network model encapsulates an input layer, an output layer, and at least one hidden layer dedicated to a complex web of calculations which may occur in a sequence or run in parallel. Such execution model illustrates the principle behind concurrent programming, through which multiple tasks can be managed simultaneously. Since our brain accepts identities, not tasks, the first step is to become accustomed not to a behavior, but to an image of self. It would be therefore more effective to say we are a person who naturally moves daily, rather than we want to work out. If changing our lifestyle were an app, our vision of our new identity would become the input layer, and the confident self we see in the mirror would become the output. Between the two lies a structured web of micro-habits our nervous system is ready to accept, the hidden layers quietly transforming intention into embodiment. But here is something essential. Those transformations are not random. They follow an architecture. In artificial intelligence, the invisible architecture that organizes how inputs travel, combine, transform, and eventually produce an output is called a computational graph. At their core, neural networks are nothing more and nothing less than computational graphs. A computational graph has three essential components: nodes, which represent either variables or operations, such as mathematical computations or activation functions; edges, which represent the flow of data between nodes; dependencies, which determine execution order. Some nodes must wait for input from others before they can operate. Others can run in parallel. If we zoom out, the graph looks like a net. Each node can branch into multiple edges, producing new nodes. The original node becomes the parent. The subsequent nodes become its children. Some nodes are dependent. They cannot execute until they receive data from their parent. This ordered transmission of information is called propagation. Propagation is the forward movement from intention to result. In life, it is the silent journey between saying, "I want to change," and waking up one morning realizing the change has already integrated. The purpose of propagation is to generate a prediction, an output, using three core learnable components: weights, biases, and an activation function. Let's use fitness to understand them intuitively. Weights determine the strength of connections or which inputs matter most. In identity change, weights represent priorities. What matters most will shape the outcome most strongly. If comfort has a higher weight than discipline, we will always negotiate workouts. If discipline has a higher weight than comfort, behavior reorganizes itself accordingly. Once we opted to get out of our comfort zone, in a further node, we come across the principle we often hear over how training starts in the kitchen, not the gym. Nutrition and caloric deficit plays a more important role in weight loss than our workout routine. Biases are constant adjustments added to shift results. In our example, we know that we should get around 7 to 8 hours of sleep. However, some days are more challenging than the others, while too much sleep can get us feeling dizzy. Biases are our internal offsets, the slight personal adjustments that make the system realistic rather than rigid. Activation functions determine how strongly a neuron reacts after combining its inputs and bias. They introduce nonlinearity. Without them, everything would be proportional and predictable. But human behavior is not linear. Sometimes a small trigger produces a large reaction. Sometimes a major challenge produces calm focus. The activation function transforms raw input into a graded response, not just yes or no, but how much. Now, here is where this becomes deeply relevant to personal growth. In his book Atomic Habits, James Clear reminds us that goals fail not because we lack desire, but because we lack systems. Goals are outputs, systems are graphs. Identity is the architecture. A vision without structure is fantasy. A system without repetition is unstable. Consistency, not intensity, consolidates identity. Every micro-habit becomes evidence. Evidence builds familiarity. Familiarity builds safety. Safety allows embodiment. Over time, the right action becomes easier than the wrong one. But what happens when our expectations exceed our current capacity? What happens when we attempt to propagate too quickly? What happens when the output does not match the intention? That, my dear friends, is where backpropagation enters the story. If forward propagation turns identity into behavior, backpropagation turns behavior into learning. And that is what we will explore next.